So in today's session, I'm going to talk about another machine learning algorithm, and we are going to implement that using a Python scikit-learn machine learning library. So that is the plan for today's session. So having said that, now if you ask me like what a decision tree is, I assume that you have already done decision trees in your data structures module. So tree structure, in other words, you have set of nodes and then what you call leaves, which we are going to use for decision-making purposes. Now, the question is in machine learning perspective, in machine learning perspective, what we do is you provide the data as the input, and we need the decision tree algorithm to learn decision tree for us. So therefore, what we are going to discuss here, how this is possible and how provide the data, the algorithm will generate a decision tree. Actually, there will be a deeper treatment. You will get this in machine learning module, but this is natural language processing. So I will briefly discuss how this is possible given a data set. So having said that, the technique we are going to discuss to generate a decision tree.
Recording in progress.
Is we use divide and conquer approach. I think somebody's mic is on. Okay. So in divide and conquer approach means simply when you are given a problem, we break the problem into smaller problems and then we solve each of those smaller problems so that you can solve the bigger problem. So this is in relation to decision trees, we call it as a top-down induction of decision trees. So the steps like this, so the first task for us to, when we want to create a decision tree structure, is we need to select a particular attribute to be placed in the root node. That means in the top of the tree. So simply, if I go down the tree structure, this is what we expect. Something like this, we expect, given a data set. So this is the tree generated from our toy weather dataset. I hope you remember we discussed about the weather dataset where we have a set of attributes and we are supposed to decide whether to play yes or no. So in the nodes, you see the attributes and the branches are the attribute values. And then you will see in the leaves, we will notice that these are the decisions. So this is what we want to, generate. And this needs to be generated from this data set, right? We have 14 instances. Now the question is how we are going to do that. So as I told you, the steps are as follows. We first select the attribute. And you mean we have several attributes. We need the best one to put in the root node, right? And then we are going to make one branch for each possible value, which means that if you have, for example, 3 different values, the idea is in default case, we are going to create 3 different branches. And then each of these branches, we are going to repeat the problem. Why? Because when you're given the data set and when you select a particular attribute, the data set will be divided into a number of branches. So that is what will happen. Okay. So, so that's the idea, right? So you repeat the process for each branch and then how do you stop? One is if you have the same classification, that means if all the instances come down in that branch, if it is in the same class, then we stop at that point. Otherwise, we will have some criteria to say when to stop this, right? So that's what we need to discuss. Right. Sorry about that. I got a ring. Okay, so let's briefly discuss how this is possible with this data set. So here we have 4 attributes, and then the final one is our target. This is what we want to predict. So given the different weather conditions, we need to predict whether to play this game or not. Right. Now, can you tell me, this is general question, so maybe I can stop for a bit. Right. Now, having said that, when you want to decide which attribute select, one way to do that is you compare the attribute with the labels. Remember, we did this in our previous algorithm, 1R and the 0R. So likewise, if you take Outlook, we know Outlook, we have how many? So if you take Outlook, in Outlook, we have 3 different values, right? So we can have 3 different values. We have Outlook, and then in Outlook, 3 different values are there. So what are the 3 different values? We can have sunny, we can have overcast, we can have rainy, right? So 3 different values. You can create 3 branches. And then you compare with the final value. So if it is sunny, we know the value is no, 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 yes, then sunny is yes. So you will have 3 no's. You can have 3 no's. We can say no, 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 and yes, and yes. Right? So you can have it like this. Similar to that, if you look at Outlook is overcast, if you look at overcast, it will be yes, overcast, yes, overcast, yes, overcast, yes, which means all the values under overcast will be yes, 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 and yes. So it look like this. Since all the attributes are classified as yes, we can finalize this because everything is the same. So what I could do is, right, instead of everything we can finalize, you don't have to create any branches. You can finalize, say that, okay, this is the final, because everything is classified as yes. Look at Outlook is rainy. So this is, say, Outlook is sunny. This is Outlook is overcast. I will put O. And this is rainy. Right. So if I put like this in rainy, for example, if you look at it's rainy, we have yes, yes, no, then again rainy, yes, rainy, no. Yes, we have 3 yeses. And 2 no's. This is how it looked like. So if you remember, initially we had 14 instances. If you count, this is the whole data set. Out of 14, this branch took 5 instances, 4 instances, again 5. So what is the next step then? You have to repeat the process. That's what we have discussed. Now the problem is we have to select whether we are going to select Outlook, temperature, humidity, or windy. Now, if you move on, now this is, if you draw the same way, if you do the same way for all the 4 attributes, this is how it look like, right? This is how it look like. Now the question is, okay, we have 4 possible attributes: outlook, temperature, humidity, and windy. Now we discuss the idea. You can choose one in random. So that means you can use any of these and create a decision tree. Otherwise, you can look for different criteria. So one common criteria is simple decision trees. That means we believe in machine learning that, okay, simple models works best. So therefore, we can look for simple decision trees. And if you look for simple decision trees, outlook attribute is better because you will see here in this branch, for example, will be terminated and the final outcome would be yes. So what it means is when outlook is overcast, then we always say the play is yes. Right? So that's the criteria that we can decide or to select outlook. Right. Assuming the outlook is the best, what is the next step then? Okay, so now my question is again, I'm going to repeat. So we have 4 possibilities and I said, okay, I'm going to select outlook based on the simple decision tree. Why I'm saying simple decision tree, if you look at the outlook overcast branch, we can finish this at this point because everything is classified as yes. But if you check all the other attributes, it's not the case. It's mixed. So therefore, I'm going to select outlook. What is the next step then? Okay, now we select one attribute. Here we have 3 branches. One branch we have finished because if everything is classified, but there are 2 remaining branches, which means we have to select other remaining attributes to put it here, right? Remember, we talk about this is, right? We discussed this idea earlier. The idea that we are going to talk about is we call divide and conquer, right? I told you, you start with the bigger problem and then you try to solve the smaller problem. You start with the 14 instances. Now this branch, you have only 5. But this is not pure. That means we have to put an attribute and see. Right? Given outlook, right? There are 3 other attributes, right? What are the 3 other attributes? We have temperature, we have humidity, we have windy. Okay. If I go back again, the question that we need to answer is, given outlook, right? We have outlook. Now we have decided to use outlook. And then overcast branch, it's done. When outlook is overcast, now we are going to end this because we know that everything is classified as yes. So everything is classified as yes. So we can finish at this point. That's one thing. But then there are 2 other branches when outlook is sunny. So let's look at what will happen. Outlook is sunny. So what we need to now identify is what will happen when your outlook is sunny. So that means we have to only look at the values here, right? What values? When Outlook is sunny, what will happen? We have 5 instances, right? Now you have to put these 3. So you can put temperature, you can put humidity, you can put windy. A small question for you. So which attribute you think is best to put it in this place? Is it temperature? Is it humidity? And is it windy? Right. Given that we have selected Outlook, right? We'll look at the next step. Now, here is the next step. This is what I have actually asked you to do. Given there are 5 instances come in this branch, we put temperature, humidity, and windy. And this is how it classifies. By looking at these 3 branches, we have 3 models A, B, C. Which attribute do you think is best in this case? Yes, anyone? Okay, Hansaka said humidity. Any other answers? Or are you confirming the same? Yes? Yes? What do you think? Are you agree with Hansaka's answer? Of course, it's humidity, provided that we look for simplicity. Because you notice that everything comes under humidity is high. That means outlook is sunny and humidity is high, then everything is classified as no, right? And this is yes. So if you, because we can end here, therefore we can select humidity. Now we have 2 branches, 2 branches we have finished. Outlook is sunny and then humidity high and normal. We have this. Now our final outcome should look like this. So sorry, here we have yes, that's final, and this is yes, that's final, and this is no. Now we have remaining 1 branch, right? This is sunny, this is overcast, and what if outlook is rainy? Now we have 2 remaining attributes. We have to decide whether we should put temperature or windy. What do you think? So we have 2 remaining attributes. We can put temperature or windy. And my question is, which one we should put? So only thing is you have to work on the data set and then you have to look at it. So the idea is when outlook is rainy, whether we should use, yes, temperature or windy. So the outlook is rainy, right? So you have to look at rainy. So these are the records that we have in that branch. How many? 5 5 attributes. We have to select either temperature or windy, right? So if you have here, if you look at these value, mild, it says yes, temperature. Then cool, yes. Cool. No, you can see it's not pure classification, right? So I don't think this will work. Try windy now. Here, this is false, yes, false, yes, true, no, false, yes, true, no. Okay, this is the one we have to select. That we will get pure classification. So that means this will be our final decision tree. Right. Now, this is a toy problem and we can work it out by hand, but in practically, if you have a very large data set, creating a tree by hand will not work. So therefore, we need a mathematical way of implementing this one. So the idea that we are going to discuss here is called information gain. I'm not going to go into detail, but let me give you the basics. So what we do here in information gain, we calculate the information before the branch and we calculate the information after the branch. The difference we call the information gain. So the idea is, if it is purely separate, the information gain is the highest value, right? So if particular attribute value can clearly separate your data, then the gain will be the highest. So that's what we do. In mathematically, we are going to use entropy formula. Again, I'm not going to discuss these things and you will learn in machine learning. But the idea is mathematically, we can calculate the information gain. As I told you earlier, we calculate the information before the split. We calculate the information after the split. The value will be in bits. And if you calculate this formula for all the attributes, you will notice that Outlook has the highest information gain, and algorithm can select Outlook as the root node, and the process repeats. Right. So that's the idea that simple decision trees are made. But there are many other techniques people use. For example, like information gain, there's another measurement called Gini index, which is again used in some other decision tree algorithm like CART, where you have what we call the binary split. That means any attribute, you have only two branches, not like in previous one, because in previous one, we assume that every attribute value, we have a branch. But Gini index actually works for binary splits. And then this is exactly what we are going to discuss in our lab session today, right? Again, Gini also calculate the Gini value before the branch and after the branch. And you can say the difference we call is under the Gini index, we call it as a reduction of impurity. But more or less, both are used in developing decision trees. Right. Now, having said that, there are many implementations are available. And in this example, I have considered only nominal data. But how you use in numerical data is slightly different from what we have discussed. So therefore, we will discuss how you can do this by implementing this. But depending on how we use, there are different versions in implementation. So if you look at the software available for you to implement decision trees, Veka is another toolbox we use for machine learning and data mining. And Veka also can be called within Python, which I think we have discussed in previously. But let me discuss today's one. We are going to use, there's a popular machine learning library called scikit-learn. In scikit-learn, the decision tree classifier available under decision tree classifier, which generate what we call the decision trees. And it supports both Gini and entropy. Gini means Gini index, entropy means our information gain. All these are used. And there are some other parameters we need to set. So I hope you understood the basics and we discuss what is important in developing a decision tree. So now let's implement from the beginning. I want you to work together with me so that you are also comfortable of implementing. Right. So let's open up Google Colab environment. And let me share it. Right. I hope everybody is familiar with the Google Colab environment, right? Yes. Hope you have done a couple of exercises on this. Can some of you confirm? Okay, let me first show you what we are going to discuss, and then I will go through the code, line by line, right, together. So that's what I'm going to do. So I'm going to open up a notebook, which is called machine learning. So let me check machine learning. Right. So this is what I'm actually going to discuss with you for the remaining 1 hour's time, the implementation. The problem that we are going to discuss is called classifying 3 different types of flowers. This is a common toy problem again. You can see visually the 3 flowers looks the same, and it's very hard for people to identify the difference. So handling this problem in machine learning area, what we do, we collect information about the 3 different flowers. So the data set, you will see there are 150 samples, and that is for 50 each for each of these different flowers. And then there are 4 measurements about the flower: sepal length, sepal width, petal length, and petal width in centimeters. So what it means simply, you get the flower and then you actually measure the 4 measurements. So that's what we do. Right. Okay. So these 4 measurements were taken and they prepared a data set. So they calculate for each flower, they have recorded this measurement together with the class label. So that is how they have prepared the data set. So what we are going to discuss in this, we discuss how to get the data set using machine learning algorithm scikit-learn, and also just looking at some basic information about this data set, visualizing the data set. First, just putting into 2D form because we have 4 dimensions, but we look at the 2D information, whether we can see, whether we can separate it out. And then you can see properly visualize data set with all the labels. I hope you have already done this in matplotlib, which I'm going to explain how we are going to do that. And then we discuss the how to build the machine learning model, which I have not discussed the whole process, but I will explain it briefly. But we select the decision tree classifier and we build the model, and then we are going to display the model. And I will explain what this model means, right? So that's the plan. So I hope you are ready to do this, right? To start with, I'm going to start with a new one. And I want you to work with me, right? And whenever you have any issues of working with me, if you're not getting the output, just let me know in the chat, right? So let's start. So I'm going to open up a new window, new Colab environment. So I'm going to say File, New Notebook. Right. Let me start from the beginning. The first step is let's load the data set. So the loading data set, actually, you have to use scikit-learn. So this scikit-learn library, if you go to this website, it's called scikit-learn.org, and it talks about everything about machine learning. There are plenty of tutorials. Those who are interested in learning machine learning, there are various ways. What I'm going to discuss today is getting some data first and performing classification using a decision tree. So again, I have referred some of the material here as well. So this library will give you access to some data sets, as well as it has extensively implemented various classification, regression, clustering algorithms. And also you can use for various other machine learning tasks, right? Having said that, let's get back to how to load the data set. Okay, now to load the data set, I'm going to use get the data set first. So the first thing I'm going to do is I'm going to get data sets from scikit-learn. So you can say import everything from scikit-learn, but I'm going to directly access it. So I will say from sklearn import datasets. So in this place, you have plenty of datasets, but what I'm interested in a dataset called iris dataset. So to get the dataset, we have to say datasets dot load iris. You can notice that our new version, it actually suggests me what to do. And then I'm going to save this as iris, right? So let's print iris and see, print iris. So you can notice that it will give us n-dimensional array here. So why I said it's an n-dimensional array, you can just type iris and then you can run it. You can get to know that this is what we will is iris dataset. And then using this, we can make use of, so let me say print type iris, right? So under this, we are going to get this. So if you look at the type, you can look at inside. It uses a data set as an array. So we can actually manipulate the array if you want. The first one is called data. It's like a dictionary. So the first one is this array of data, the first part. And the second part is the target. That means we will get the labels and so on, right? For example, we can say iris.data will give you only the data set, right? Again, you can look at the type of this. it is a NumPy n-dimensional array, right? Okay. Yes, finish up to this point. Right. The next part, now in here, you can see that, okay, data is what we have as an n-dimensional array. Similar to that, you can see you have target. So for example, if you just type, okay, I put earlier iris.data, which gives you only the data points. Yes. Similar to that, if you look at target, so target is actually the labels. The first one, you have only 4 records, which means the measurements. And if you say target, so the target will be just the labels, right? So this is what I'm going to discuss the next one. So I'm going to separate my data and the target because I need to see. So therefore, what I'm going to do as the next step, I'm going to say capital X as my data set. I will say iris.data and simple Y as iris.target. By doing this, what I did actually is I took those two, data and target, put into 2 variables, X and Y. I can say print an X and Y suggested like this, but there's no point. Let me just take the first 10 rows. So what I can do is I can say print, if you say capital X, it will print everything. But if you say 0 to 5, first 5 rows, likewise, I can put 0 to 10. This is also working, right? But actually you don't need 0. You can just remove, just like this colon and 10 will give you the same answer, which is the first 10 rows. So you can notice that if I print only X first 10 rows, this is what are the values. So these are the 4 attributes. Similar to that, let me print the first 10 labels. So if I first 10 labels, you can see it's come from the 0. Actually, this 0 also represent the class labels. If you look at the target names, it says target earlier. Target names Setosa, Versicolor, and Virginica. That means 0 is Setosa, 1 is Versicolor, 2 is Virginica, right? So if you do this, right, you can see 10 records from the data set, and these are the labels. Right. Those who have finished. Okay. So my next one is like any machine learning problem. The first task is, you just look at what you have. You can look at the statistics, or you can just simply visualize it. Because we right now know there are 3 groups in the data set. We can, by plotting this data set, we can see whether we can find the 3 groups, right? Simply we could do that. Okay, so now let me see, to plot something, we know that we have to import matplotlib.pyplot as PLT. That you already know, right? So that part I will do. Now the next point is we have to visualize this. Actually, it will give you the code right now. You can see in my window that now automatically it suggests me the code, but let me use simple plot command. And let me use plt.plot. Now we know that when we say plot, we have to say, okay, what to plot, right? So when you say what to plot, we have to select 2 attributes, right? So what I'm going to do, I'm going to say okay, I'm going to get X, let's say colon, and then let's say 0 will be my first row, and then X colon and 1 the second row, right? And then let me just show this plt.show and see what will happen. This is not the final answer, but I just want to draw and see. I miss the brackets. So you can see something like this because, you know, it's a line plot. Therefore, I can put just O where I need a scatter plot. Oh, you can see scatter here. You can see it looks like this, right? This is the first column and this is the second column. Let me put the third column. I will put 2, 0, 1, 2. That's the total. So I'm plotting the first column and the third column now. So if I do that, it look like this. Yes. So let me put 2 here and this is 0 here. I purposely do this because I have worked with the data set for some time. So I know which looks better. So therefore, I selected the third column as the x-axis and the first column as the y-axis. So let me change the color. I will put R. So I think this looks good. And this is what I'm getting. Right, good. Right, now what we have observed is, let me show you the full graph. Right, now can you tell me your observation? What do you see in this graph? Remember, original data set, we have 3 groups. What do you see from this? What conclusions you can draw from this? Yes? Especially those who are working in the data science, you should practice this skill. Given this data set, what do you see? What you can observe from this data? Remember, we have 3 different types of flowers. Yes? So one thing by looking at this, you can say that, okay, one set of data can be easily separated from other 2. But we don't know which other 2 because it's not very clear. So let me explain how to filter the data and separately, you know, plot this, right? So this is what I'm going to discuss next. Right, let me go to the next part. So what we have discussed earlier is now we got the 2 data points and now we want to filter those data points. Now filtering can be done in various ways. For example, now what we said was X colon. When we say colon, what it means, all the rows, and then we'll say, okay, I need the third column. So if you print like this, right, you can understand what it means. So it'll print the third column of the data set, right? So it should print the third column. Yes, agreed. Now the point that I want to make is, I want only when the class value is 0. So I don't need all the data points. Here we have 150. Therefore, instead of putting this, I will check something like this. This you should have done in my previous lab classes. So I won't make it only the class label when it is 0. So I will put this, the meaning of this is I'm going to get only the data points where the class label is 0. So if I put this, so you can notice that I'll get only 50 data points. So by doing this, what we do is we get the third column where the class labels are 0, right? So I'm going to get that data and plot. So what I'm going to do is I'm going to, instead of put this, I will say, okay, plot, sorry, plt.plot. So I will get this. This is X, that means the 50 points, that is 1. And then I will say X, again, Y colon is equal to 0. And then we will put 0 to get the first column. And then I will use red color, right? So this is exactly what I did, but this time I filter the classes. So this time we are getting 0 means setosa, right? Remember I told you earlier. Here the class label 0. Class label 0 means the setosa. Similar to that, then we have the second class. So I will put here, I'm going to change 0 to 1. And this is also 0 to 1. And now let me use green color. I will put G here. So now I plot only 2 data points. So now we have put 2 classes. Similar to that, let me put the third data point. So we will have 2. And this is also 2. Let me put this in blue color. Let me put B. Right. Now you can see the 3 classes. So you can see that the red class is clearly separable from blue and blue. So green and blue, right? Right. Let me put the values as well, because otherwise it will not be complete. So let me put the labels. So let me first say that put a title. I will say, okay, plt.title. I will say this is iris dataset, right? And then we will say plt.xlabel. This is petal length. And then plt label. It's sepal length. Then let me put the legend. The 3 values are, right? Setosa. Actually, we can say iris.target names, that the labels we can handle. Then we can say plt.show. Right. Okay. So let me run this. So you can see now it's clearly separable and nice and clear. And we can notice that the setosa, class setosa, is clearly separable from vesicle and virginica, flower classes. Right. So what we did here, simply we separate out the data based on their classes, and we put 3 different colors so that it's clearly visualized. And we also put the labels for the title, x-axis and y-axis labels. Visualization. And you can notice that versicolor and virginica is a bit difficult to separate, but setos are clearly separable. So that is what we can, observe from this visualization. Now, next part, I'm going to briefly explain machine learning process. So remember, one thing we have to discuss is, given a data set, we want to make prediction. We are not going to use the whole data set as it is. Instead, I will come to this point later on. We divide our data as training and testing. So let me explain how you do that. To separate our data as training and testing, I'm going to use scikit-learn dot model selection, and I'm going to import, there's a function called train, test, and split, right? So this is train, test, and split. This is the function I'm going to use. So under that, I can actually separate out as X train, X test, Y train, Y test. I'm going to use the train size as 33%. That means 1/3 of data I'm going to put as test data. And then I'm going to use 2/3 for train. So that's what I'm going to do. So let's look at the shapes. I'm going to look at print X train shape, extend shape. And similar to that, we can see Y train shape, Y test shape. So let me run this. I hope you remember we had 150 data points. And out of 100 data points, you can see X train shape is 104, which means we have 100 records with 4 columns. Test set, we have 54 columns. The target, that is the class label, we have 100 data points. And test, we have 50 data points. So now we are ready to build the model, right? This is to build the model. There's a question, the division of the data set, whether you are going to have 50%, 70%, 80%. I mean, there's no fixed rule says, okay, you should go for 80% and 20%, right? But different researchers recommend different divisions. What I usually practice is 2/3 of data I will take is as a training and 1/3 as a test set. But there's no universal agreement on these divisions. So some people use 80-20, 50-50. So it totally depends on your requirement, right? Okay. But for me, I have been practicing, machine learning for about 2 decades now. I prefer to use 2/3 of data as training and 1/3 of testing. Of course, it depends on the dataset size and all, because this is a smaller dataset, right? So I use 2/3 for training and 1/3 for testing. But when you want to have rigorous testing, that means you have to focus on more testing, then you can increase the test set size. There's no, that's why I said it's flexible, but people use different numbers, so you can also decide which number to use. But if you do not have any clue, maybe you can choose mine, which is 1/3 we take as a testing and 2/3 we take it as a trade. Okay. So having said that, let's move to the next one. Now you divide the data set, and then you have to, select and then build the model. So we are going to use decision tree model. So let's decide on this one. So I'm going to say from scikit-learn, I will say import tree, which means I'm going to select the decision tree classifier. So to do that, I will say classifier, or you can say CLF. and I'm going to use tree decision tree classifier. And within bracket, you can actually put a lot of parameters, which I'm not going to focus right now. I'm going to just use it as it is. So this is the decision tree model. I'm going to select the decision tree. And then we have to train the model. Now training, usually we will say classify, we are going to fit the classifier. So we will say classifier from the previous step dot fit, and I will provide the training X train and then Y train. So it uses the training data to build the model. So if you run this, this will create a classifier, which is a decision tree model. Now that we have fit the training data, let me visualize the tree. So there I will actually give you the code for this. There are many ways that you can visualize. I will put the code in the chat. Simply, I use the basic version of the decision tree. So this will give us a tree structure with something like this. So the command I have used is called tree.plotTree, which I provide the classifier and provide the other information we need. We have to provide the feature names, class names, and other information. You can try out here by changing. For example, you can, if you say fill true, you can remove the colors and things like that. You can try it out by just changing the values here. For example, if you say false, and if you run it, you will have a black and white, right? You can try those. Now let me explain what this means. If you carefully look at the decision tree structure given here, right? What you notice here is it will check the petal width. If the petal width is less than 0.8, that's what it says. Then it says the class is Setosa. You can see out of the training data, 100%, 31% goes to Setosa, which is, you can see, compared to other classes, earlier we have seen by visualizing Setosa is the easiest class to separate, and this is evident in this decision tree as well. Because when petal width is less than 0.8, all the data will be classified as Setosa. And this is evident here as well. But the other two, you can see there are a few lines. For example, if the petal width is not less than 0.8, then you check whether the petal width is less than 1.75. If it is yes, then you have Virginica. Otherwise, it says versicolor, but you see there are like some misclassifications. And then if the sepal length is less than 4.95, then it says Virginica. right? So you can see that by looking at the tree also, we can observe that the two classes, virginic and versicolor, are difficult to separate. So there are overlapping here as well, right? So that's how we can actually plot the decision tree. Now, of course, how accurate this class can be done by looking at the predictions. So what I'm going to do next is we can actually see the predicted values. For example, I can say we have classifier. We can print, okay, classifier dot predict. We can say X test. X test means we have separated out the data as training and testing. I'm actually testing this. So you can see out of 50, these are the predicted values. You build the tree model and tree is predicted. What are the actual values? Let me check. The actual values we have stored under Y test, right? So if you compare the two, you can notice that a lot of cases, they are okay. Lot of cases, we see the same values. 1 1 1 1 2 2 0 0 2 2 2 2 0 0 0 0 0 0 0 0 2 2 2 2 1 1. Okay, here there's a error, right? Prediction is 2, actually is 1, right? You can see there one error. Other cases looks good. This is also there's an error. Others looks good. There's an error. Others looks good. Okay. And here 1 0 C 1 2 2 0 1 2 0 0 2. Okay. So there are 3 misclassification, at least in my case, right? So we can actually look at it in the report as well. You will learn again this in machine learning, how you do that. But this is called generating confusion metrics, and looking at the accuracy, so that we can say how accurate our model is. So that part is already there, right? So we can actually calculate the accuracy. So to calculate the accuracy, you don't have to look individually. What you can do is there's a the function method we call scikit-learn dot metrics we say import accuracy underscore score, right? Actually, it's fill out the data, right? So I'm going to scikit-learn metrics. Yes. So if I do this, you can see, okay, there's an error. Okay, okay, LEAR. Okay, there's a spelling mistakes. It says 94% accurate. That is correct, right? In my case. In your case, it might be a different value because it might create slightly different answer for your case. So in my case, I had 3 misclassifications out of 50. So the accuracy is 94%. Right. Any questions from what we have discussed so far? Okay. Just to summarize what we have discussed, we discussed the theory of building a decision tree from the data. We discussed basic ideas. And then finally, we look at the implementation using scikit-learn machine learning library. So I hope with that, you now have a basic understanding of how we use machine learning to make some, or building a model and make some predictions, right? In this particular case, actually, we have actually visualized, because the decision tree models are, you can visualize easily, and you can understand how the decisions were made. And this is not possible for all the machine learning algorithms, right? So that is one of the advantage you will get by using decision tree algorithms. Okay, guys, if you have no questions, then let me finish for today, and hope to see you guys next week. And I will post all the information, including the video and the code in the LMS. Thank you.